a good TV show. Roots. And I think, did we draw all these down? We have, well, specifically today we're talking about square roots, so that kind of narrows it down. But we have the perfect squares, right? Roots can be kind of difficult to work with, but we have ones that work out perfectly. For example, the square root of 1 is even, didn't we? What's the next perfect square? Which one? What's the next one that works out evenly? Square root of 4. Have we done this or no?
Yeah.
And then you have the square root of 9, which is 3, and then the square root of 16, which is 4. But what happens when you get to something like this? The square root of 200. Wait, maybe it's not. I'm sorry. Let's change that to the square root of 400. Square root of 400. Please, please, please get it out of your mind that this has anything at all to do with division, because it doesn't. The answer to that is not 200. 200 times 200 is not 400. It's like 40,000 or 400,000 or something like that. All right? And there's no easy way to do square roots that you don't know. Really, the only way you can do it is by either getting a calculator, which I don't let you use, or you have to do trial and error. Which means you got to sit there and try to guess what it is and see if it actually works out. Now, the square root of 200 or 400. You know, what would be a good guess? Well, some ones that you already know. You know 10 times 10 is 100. So that's too low, so you got to go bigger than that. Maybe you know that 12 times 12 is 144. Some people know that. 13 times 13 is 169. But, you know, the next thing I would try is the next even number. What is 20 times 20? 400. So there is no magical mystery whatever thing to try to figure out square roots. It is just trial and error. However, Samuel, there are a whole bunch of square roots that don't work out. As a matter of fact, most square roots don't work out. Most of them don't work out. Which means you need to kind of figure out a way to estimate them. Because they are numbers. That doesn't work out very well. Estimate. I wish I could see that. Estimate. And the way the book kind of introduces you to do this, it will tell you something like this. Here's your example. The square root of 75 is between what two whole numbers? Okay, what two whole numbers? In other words, between what, where would you find the square root of 75? And for that you have to think about the perfect squares. For example, you know that the square root of 64 is 8. The square root of 81 is 9. Well, the square root of 75 has to be somewhere in here because it's between 64 and 85, or 81. So you know that the answer to the square root of 75 has to fall somewhere between 8 and 9. And that would be the answer to this. It's between 8 and 9. So at least you have a reasonable guess. Or if I said the square root of 18. The square root of 18 would be between what two numbers? Again, you have to think about the perfect squares that you do know. Maybe the one above it and the one below it. What perfect square do you know that's just a little bit, Brennan?
6.
The square root of 16 is 4. What's the next perfect square after 18?
25.
Yeah, the square root of 25 is 5. So you know that the square root of 18 has to be between 4 and 5. Which one?
Is there such a thing, Mr. Hunt?
What's that?
Does that really exist?
What's that?
A square root of
18? Sure.
Are all numbers, they all have square roots?
Yeah. Well, it's irrational though. It doesn't make sense because it
It
doesn't
doesn't
work out.
make sense.
It doesn't work out evenly ever. If you were actually doing it. Square root of 18 between 4 and 5. Which one would you suppose it's closer to? Is it going to be closer to 4 or is it going to be closer to 5? 4, because 18 is, as a matter of fact, we could do it. Let me pull out Mr. Calculator. And I'll actually get the square root of 18 is, 18 square root is 4.242640687119 It stops because the calculator ran out of digits. It would go on forever. It's just the way, that's why pi never runs out, because it's one of those, we call those irrational numbers. They don't make sense because you can't get to the end of them. That's just the way it is. What else do we have here? How about the square root of 99? Square root of 99 would have to fall between what two numbers? Well, the next one after 99, the square root of 100 is 10. The one before it is square root of 81, which is 9. It's awful close to 10, but it's between 9 and 10. It's somewhere between 9 and 10. Somebody gave you the square root of $100, you would have very close to $10. What are these numbers greater than 6? Okay. And that, ladies and gentlemen, is pretty much the sum of all things.